The first example that we're going to look at, we're first just going to review how to find the domain of a function. So in the warm-up, you learned how you reviewed domain and range. But now let's look at finding the domain for this function here, the function x squared plus x minus 6 over x squared minus 3x plus 2. Now notice I have the function graphed. So to help find the domain, as we said in the steps before, we're going to factor. I'm going to go ahead and factor the numerator and the denominator. So the top factors to x minus 2 and x plus 3. And the denominator factors to x minus 1 and x minus 2. Now, if you look at the function that you have graphed here, it appears that we have a vertical asymptote at x is equal to 1. So at x is equal to 1, we have this imaginary vertical line that we cannot see, and you see that the graph does not exist there. Okay, also in this graph, notice how we have a horizontal asymptote at y is equal to 1. So again, the graph does not exist at y is equal to 1. There is this imaginary horizontal line. But what you can't see in this picture is a hole. In this function, we have a hole located at x is equal to 2. So if I go to 2 on my x-axis, right here at 2, 5, there would be an open circle. You wouldn't be, you can't see it when you graph it using Desmos, but there is an open circle there. The only way really that you can tell is by going to your table of values, or of course knowing how to do it by hand. So now that we know that, looking also at my domain, I can tell my domain that x cannot be equal to 1, but x also cannot be equal to 2, because my function is undefined there. So I have a domain from negative infinity to 1, then also from 1 to 2, and then from 2 to infinity. So this domain is broke down into 3 parts because of the 2 places where the graph doesn't exist. So now, how to find those vertical asymptotes and those holes? So going back to the 3 examples that we had at the beginning, the examples of a polynomial, well, the key theme to all of this has been to factor. So to find your vertical asymptote in your hole, you have to factor the numerator and the denominator. The factors that are the same in both the numerator and the denominator are known as your holes, or discontinuity in the graph. So if I have an identical factor in the top and the bottom, and that factor has canceled out, then that is considered a hole in the graph. The remaining factors in the denominator are known as your vertical asymptotes. So let's look at these 3 examples. So in this first example, x plus 1 over x minus 2, I can't simplify this. So because I can't simplify this function, there's no identical factors in the top and the bottom, then we have a vertical asymptote at x is equal to 2. Okay, remember, 2 is the number that if I plug into that function, 2 take away 2 is going to give me 0. So I have a vertical asymptote at 2. Okay, in the second one, which is the one that we just looked at, how we got that whole. So we want to factor the top and the bottom. So x minus 2 and x plus 3 is how we factor the top. And then the bottom is x minus 1 and x minus 2. So notice how we have identical factors of x minus 1 on the top and the bottom. If I was simplifying this, those two factors would cancel out. Well, because those two factors cancel out, that is my whole. I have a whole at x is equal to 2. And so the remaining factor in the denominator that did not cancel out is my vertical asymptote. So I have a vertical asymptote at x is equal to 1. And so then now the next function. So again, in order to be able to determine the wholes and the vertical asymptotes, we've got a factor. So the top factors to x plus 1 and x minus 2. And then notice how we've got this factor of x minus 2 in the denominator. So, because we have identical factors of x minus 2 in the numerator and the denominator, they cancel each other out, which means, yep, you guessed it, that's my whole. So I have a whole at x is equal to 2. Because that factor canceled out and there's nothing else left in the denominator, this function does not have a vertical asymptote. So there is no vertical asymptote. When we start to graph these, you're going to see, start to see why this is and what these functions are going to look like and why you need to know how to find these by hand in order to have a better understanding of the graphs. So, vertical asymptotes and wholes to review. So I'm a whole. If I have identical factors in the top and the bottom, that's a whole. The remaining factors in the denominator are my vertical asymptotes. So now the third and final step to graphing rational functions. This concept's a little bit harder, but to graph the horizontal asymptotes and how to find the horizontal asymptotes. So go through and read through the next part on your notes, horizontal asymptotes, and there's 3 cases that you're going to learn about.